Hello and welcome back to Joe Bailey Revision. Today we're going to be looking at Chemistry Topic 9, which is all about the chemistry of the atmosphere. So let's start with Earth's current atmosphere. So Earth's atmosphere stayed the same since 200 million years ago, which means back then it's the same as it is now. And the composition of the atmosphere is made up of 78% nitrogen, 21% oxygen, 0.9% argon, 0.04% carbon dioxide, and 0.06% of other gases. The really important things to remember here is the carbon dioxide, the oxygen, and the nitrogen, because they really play into how the actual atmosphere has changed since Earth's early atmosphere. So Earth's early atmosphere, in the first billion years of the Earth, volcanoes formed. And what normally happens with volcanoes, these volcanoes erupted. And the eruptions released carbon dioxide, ammonia, nitrogen, water vapor, and methane. The methane from these eruptions is still present, as there's still methane in the air making up the other gases. It was just a really small trace amount at the time, and is now. Carbon dioxide was produced, and the important thing about that is most of the atmosphere back then was made up of carbon dioxide, not nitrogen like it is now. And we'll look at how that changed and how extra oxygen was produced. Also, there was ammonia, but later on that would react with oxygen to form more nitrogen, increasing the amount of nitrogen. And the water vapor would eventually condense to form oceans because the Earth would cool. And this is important because it produces water, which we'll look at in a minute. So, in Earth's early atmosphere, on the Earth, algae formed. And algae is basically this basic form of life that was in the water, and it could perform photosynthesis. So, by performing photosynthesis, it could create oxygen, and glucose, but oxygen's the gas, from water and carbon dioxide. And it could get the water from the oceans, and it got the carbon dioxide from the carbon dioxide in the eruptions, which we know there was loads of at the time. And because the carbon dioxide is turned into oxygen, that means that carbon dioxide from the atmosphere is taken away and transformed into the oxygen. So this meant that this process would happen more rapidly as plants evolved, because plants evolved to become greater at photosynthesizing, meaning that over time, a lot more carbon dioxide would be turned into oxygen. And also, this process continued to happen until animals started to be able to survive. Animals like humans who breathe in oxygen. That wouldn't have been possible in the Earth's early atmosphere, of course, because there was no oxygen there at all. So, also another thing that led to losing carbon dioxide is that some of it became fossil fuels and sedimentary rocks. So yeah, this would just form into those over a long period of time. Yeah. Also, as we're talking about nitrogen, it goes up because the ammonia, it reacts with the oxygen, and it can react with more oxygen. If there's more oxygen present, the oxygen is created later on here in the photosynthesis. So that's how that process happens. So next, let's look at greenhouse gases. So greenhouse gases are trapped in the atmosphere by solar radiation. And these greenhouse gases, they keep the Earth warm enough to sustain life, and they do this by absorbing infrared radiation when it comes in to the atmosphere. So the infrared radiation comes in, and it would normally, a lot of it would just leave, but more of it ends up staying with us because of these greenhouse gases. So they actually sort of help by helping us heat the planet so it's good enough for us. So yeah, the infrared radiation would have left before without. So greenhouse gases include methane, carbon dioxide, and water vapor. So next, let's look at human impact on greenhouse gases. So humans often increase greenhouse gases, so they increase the emissions of them. And the two main ones they do this with are carbon dioxide and methane. So carbon dioxide is increased by burning fossil fuels, which is done in processes like heating and stuff like generating electricity, and also deforestation. So if you knock down trees, that releases carbon dioxide as the trees stop containing the carbon and photosynthesizing. So next is methane. So methane is produced by cattle farming, rice farming, because cattle produce methane, and landfill sites, because when rubbish is left in landfill sites, over time it produces a lot of methane. So that's another reason why recycling helps the environment. So, talking of recycling, let's talk about the carbon footprint. So, the carbon footprint is the total amount of CO2 and other greenhouse gases emitted over the full life cycle of a product, service, or event. It's very important when we consider this because sometimes things like businesses are against it, because to keep a low carbon footprint, it tends to cost a lot more and it's a lot less convenient. Like, if you're trying to keep it low, it might take a lot more time to do a process because you're trying to waste less energy. Also, a personal carbon footprint. So this is how much greenhouse gases are produced by an individual. So this is used by people when they want to reduce their emissions. So they'll do things like use less electricity, use less transport, do recycling, and eat less meat. And as we can see, this directly correlates to the stuff over here. Because if you think about it, using less electricity reduces the burning of fossil fuels. So does using less transport. And recycling uses less landfill sites. And eating less meat reduces cow farming. So as you can see, changing that links to the opposite of increasing, which makes sense. Also, the human impact on it leads to global climate change. So the main part of global climate change is global warming, and that's the increase in the global average temperature. The effects of global warming include changing habitats, which can lead to extinctions, as animals that were adapted to live there no longer are. Changing rainfall, which can lead to droughts and floods because there's not as much rain there as there used to be, or there's way too much. So it kind of messes with that whole system, the rain cycle. And also melting polar ice, and this leads to rising sea levels, and it's mainly in the Arctic. Okay, so next let's look at atmospheric pollutants. So atmospheric pollutants. So combustion of fuels creates atmospheric pollutants, and the fuels include oil, coal, and natural gas. So in combustion, carbon and oxygen are combined together to make carbon dioxide, but this is only if it's produced with enough oxygen to be called full combustion. If there's not enough oxygen, it can create carbon monoxide and carbon particles, also known as soot, which are classed as atmospheric pollutants. So next, another thing in combustion, sulfur and oxygen can go together to make sulfur dioxide, and this happens in most reactions, and sulfur dioxide is an atmospheric pollutant. Also, nitrogen and oxygen can combine to make different nitrogen oxides, and normally nitrogen wouldn't react with oxygen. However, in this reaction there is a large amount of heat, meaning there's extra energy going into it, and it can sometimes charge it to combine. So now we know all about them, what are their properties and effects? So carbon monoxide is colourless and odourless, meaning it's hard to detect. It's a toxic gas which poisons the body and can lead to a lot of health problems. Sulfur dioxide and nitrogen oxides can cause acid rain, which corrodes buildings, where it breaks down the limestone and stuff. It damages plants, such as trees. It pollutes rivers and can kill wildlife in rivers, like fish. And it can cause respiratory problems. Properties and effects of particulates. Particulates are like microscopic matter, like soot. It causes global dimming, which decreases the light by decreasing the solar radiation that can get into the planet by blocking it. And also it can cause respiratory issues, as if you think about it, these are like tiny little microscopic things, so if they get in your lungs, that can do some serious damage by blocking things if it builds up. So yeah, that's chemistry of the atmosphere, chemistry 9, paper 2 of course. Thank you for watching. Joe Bailey Revision, goodbye.